Hello folks, we come to the part 1 of the exercise 16.2. We saw in the previous exercise we're just listing the events. Events are nothing new to us. We have learned it in the 10th standard, 9th standard and all that. So we have just listed the events which were given to us. We were listing it. Now in this exercise 16.2 we are learning two things. One is called as mutually exclusive events and mutually exhaustive events. Two events are said to be mutually exclusive if their components there is nothing in common between them. Basically these events, they are two set. Between these two set, when there is nothing common, when they are disjoint, that time we call these events as mutually exclusive, and their probability, therefore if you take the intersection, that will be probability will be 0. That's about mutually exclusive. There is also something called as mutually exhaustive. Two events are said to be mutually exhaustive if the union of those two events will give you the universal set, or probability of the union of those two sets will be 1. That way, both ways you can consider. That's how you get the exclusive and exhaustive events. So in this exercise at length we are going to check the exclusiveness and the exhaustiveness of the events we are trying to list, many things. Okay. So maybe we can start right away with question number 1. It says that you are throwing a die, and while throwing it, the event E is that it is showing 4, and the event F is that it shows an even number. So with both these, you have to list these events and check if they are exclusive, and you have to tell if at all it is or if it is not. So we can start traditionally, but depends on how the question is. You should write it like that. Let S be the sample space. Traditionally we write it like this, but depending on the mark you can cut short or expand your steps. Let S be the sample space. Now because it's a die which is thrown, you know that the sample space has got these many these many components are there in the sample space. And let's see what is E. Also, your event E is that it will show 4. So it will show 4 means it will show 4. There is nothing else. Then F is it will show an even number. So out of the given lot, let us check which are even numbers. So they are 2, 4 and 6. So these are even numbers. Now what we have to check, if they have to be exclusive, you just check if there is any intersection elements, common elements between E and F. So when we check between E and F, there is a common element 4. If there is a common element, it will not become exclusive. That's the thing. So we'll write here E intersection F, there is an element 4. Therefore E comma F are not mutually exclusive. Yes, so they are not exclusive. Now we are going to the question number 2. Here also you have, they say that you are rolling a die, and then they say that a die is thrown and describe these events. Events are there on the board. Now these events are listed, and after we have listed the event, we have to tell what those things which they have asked us, what it would be, that you have to find out. So it's okay, right away we can start, right? A, they say, is a number which is less than 7. So in a die, the number which is less than 7 is all the number, isn't it? So it can be 1, 2, 3, 4, 5, 6. Traditionally you can start, let us be the sample space, and you can list the thing, and then you can start like that. Then B is a number which is greater than 7. Now that is empty. In a die you can never have a number which is greater than 7. So there you don't have anything in that set. Then C is that it's a multiple of 3. So if it has to be a multiple of 3, it can be only 3 and 6. Then D, it's a number less than 4. So the numbers which can be less than 4 is 1, 2 and 3, because they have told it is less than. They have not given the equal to option. E is an even number which is greater than 4. The even number greater than 4 is only 6. Then F is a number not less than 3. So you should have a number which is not less than 3. It can be 3 and more than 3, but it cannot be less than 3. So it can be 3, it can be 4, it can be 5 and it can be 6. So that's about it, right? So these many specifications are there over here. On the basis of this, let's go across and solve this. A union B is actually A union empty set. A union empty set will be always A itself. So it will be A. You can write if you want A union empty set, which is A itself. Then A intersection B. So A intersection null set is null set, right? Then B union C. B union C is null set union C, so that is C. Then E intersection F, that we can see. E intersection F is element 6. Yes, it's clear. D intersection E. There's nothing common between D and D. Just check, nothing is common. So it's an empty set. A minus C. From A, remove the common elements. You look at the set A and you look at the set C. So for this, you can just check A intersection C, common elements. Between A and C, the common elements are 3 and 6. Remove that from A. Yeah, from A, remove 3 and 6. So we are left with 1, 2, 4 and 5. D minus E, same way. Look at the intersection between D and D. Between D and E, the intersection is empty, so D minus E is going to be D itself. So it's 1, 2, 3. Whenever the intersection is empty, you just write the first set. Then E intersection F complement. Now before that, we'll write F complement, so that's easy for us. What is F complement? Everything that is there in the universal set, but which is not there in we should have written for the sample space S equal to, should write it right in the beginning, but still better late than never. Yeah, so F complement means everything in F which is not there in the those elements which there in S is not in F. So 3, 4, 5, 6, F complement is going to be 1 and 2. E intersection F complement. E intersection 1 and 2, nothing at all. Again, that is an empty set. So that's about it. This is what they ask us about different things, how we, whether we are able to list, and then whether we are able to find all that. So that's about it. With the remaining problems, we are meeting in the next part of the video. Thank you.